Okay, this is day 3 notes, part 2, and I've already gone in here and highlighted the bases of our two shapes. This is a pentagon, and then our cone, the base is a circle. And we need to find the height, and remember the height always goes from the base to the vertex. So in this case, our height is right here. And in this case, our height would be right here in the middle, but I don't have that. I did on both of these give you also the slant height. Here's the slant height on this one, and here's the slant height on this one. So let's fill in what we know so far. I know the slant height on this one is 23 inches, and the height is this right here. I'm going to go ahead and do this one too. The height, I don't know the height, but I do know 14 is the slant height right here, and I do know that the radius is 6. I'll just fill that in for now. Okay, so let's go back to this one and finish this one up, and then we'll move on to the cone. So the perimeter of a pentagon is one side, which is 14, times how many sides I have, which is 5. So my perimeter is 70. And then my area of the perimeter, well, this is a regular polygon, so I'm working off the 1/2 AP formula there. So the apothem is this number right here, which is 9.63. And the perimeter was 70 that we found right there. Then I can plug that in my calculator and I get 337.05. And then I can use my formulas that we had on the other side. We're just going to take and copy these same formulas from this side over to the other side. So I paused the video, I copied these formulas from the other side, I went into my blanks up here to find the right things to plug into each one of these, then I plugged each one of these in my calculator to get the answers that I have over here. So you should pause the video so you can do that. Okay, so now that you've got this copied down, we're going to finish this one over here. We were talking about earlier that this is the slant height, this is L, this is R, but I don't know what H is. It would be on this side right here. So I'm going to have to use Pythagorean theorem. I know this is 6, this is 14, and I want to know what H is. So I need to do 6 squared plus H squared equals 14 squared, and what I find is H is 12.65. Now that I have that, I can just copy these formulas right here down from the other side, where we wrote them right here, or off of your formula chart. Remember, when you copy the volume one down, it has the big B in it instead of R, but area of a circle, the base is a circle, is just pi r squared, so we're just plugging in pi r squared. Now just plug in L, R, and H from up here, being careful to get the L and the H in the right places. I plugged in all these values from up here in the blanks in the right places, and then I left these answers in terms of pi. So you see pi in my answer. I did not push the pi key. I did not type in 3.14. I'm not going to do this part on here, but sometimes it asks you to go ahead and plug in 3.14. Sometimes it asks you to leave it in terms of pi. We just left these in terms of pi. Okay, and then this is actually the one that's kind of new here. And I put a little note on here that says on day 2, we did composite figures by combining the bases. If you remember, we had that shape with the rectangle with the triangle on top of it, and we made that all the base. Well, why will that not work with this type of problem we have here? Well, the bases are not on the same side, and the heights of these two things are not the same. So I can't do it that way. So for this, we have a method 2, where we're going to take and do the two pieces totally separate, and then just add them up at the end. This way is a little bit more complicated, but for a shape like this, there's no other option. So I'm going to start, and I'm going to do the prism first. So for the prism, this is the base. And a good thing to figure out is the base the same on both of these? Well, it is. The base is actually the same shape on both of them. So when I find the P and the B on both of these, I can use it for both of them. So for instance, what's the perimeter of this? Well, it's a square and each side is 10, so the perimeter is 40. And it's also 40 up here. And then the base, it's a square. 100 times 100 is 100. 10 times 10 is 100. And 10 times 10 for this one, also 100. So that part's actually a little bit easier on this one because they have the same base. What's the height of the prism? Well, here's the height of the prism right here. It's this 32. Notice it's perpendicular to the base just like we did before. And the height of the pyramid goes straight up from the base to the vertex. So it's this number right here, 10.91. And the slant height of the pyramid is this one right here, which is 12. Now that I have these filled in, you'll notice I only did lateral area and volume. Because these, I don't need the whole surface area. Because this right here, this part is actually sitting on that, so I don't need the whole surface area of those. So I'm just going to find the lateral area and volume of both of these. I'm going to write the formulas down. And you do want to be careful that you're getting, these are the formulas for the prism, and these are the formulas for the pyramid. It's not the same thing. And then be sure you're plugging in the right numbers. So this is, these are the numbers off of this one, and then this one. And then over here I'm plugging these numbers into this one. Now, just plug these in your calculators to get these numbers. Volume is always pretty easy to do because it's just the volume of this one plus the volume of that one. We're talking about if I poured liquid in, how much would it hold? Well, the volume of the whole thing is just the volume of the two added together. So I just take these two numbers and add them together to get this one here. So I'm just going to do this to get this number here on my calculator. Surface area is a little bit more tricky. Remember, lateral area is the area of the sides not including the bases. So this lateral area right here covers all these pieces right here is this lateral area. And this lateral area over here is all these triangles up here. So if I add those together, I've got this top part, I've got this part. Which part do I not have? If I wanted to cover the whole outside, what have I not got yet? Well, I wouldn't have the very bottom here. So I need this lateral area plus this lateral area plus one base on the bottom. So for the total surface area, I'm going to do this lateral area plus this lateral area plus one base. And this is the part you'll just have to look at each problem carefully and decide what do you need. So I've got these. Plug that in my calculator and I get this as my answer.